Hello guys, good evening everyone. Welcome to this session and welcome to the India's most comprehensive preparation platform, the BYJU'S Exam Prep. And this is Rakesh Talreja welcoming you all to our platform once again. And as I announced that, yes, we are going to take up the digital electronics sessions. Yes, to begin off, the concepts of digital electronics, we have, chosen to start from latches and flip-flop, as we all know that this is one of the very fundamental topics. Yes, one of the very fundamental topics and important topics, because sequential circuits is a part where most of the students face little bit of the difficulty. And if you really want to be comfortable in the sequential circuits part, counter design, FSM or shift register, counters, everywhere you need the latches and flip-flop. Without the understanding of that, of course you will face difficulty in the sequential circuits. So first let us focus on sequential circuits, and then let's move on towards the other topics. Yes guys, very good evening everyone. Right, and keep joining the session. Do keep on sharing the session with your friends, so that many of the GATE aspirants, those who are going to appear in the GATE 23, GATE 24, especially if they have any difficulties in the subject of digital electronics. Usually digital electronics is a light going subject, easy going subject, right? This is the area where you can expect good questions, the sequential circuit part, and that is why let's focus first on the latches and flip-flops. Right, the complete idea about digital electronics I gave you in the last class. That was just a generic session ki how to prepare for digital electronics, what are the important topics, what are the books, what books to refer for practice, what books to refer for theory, how many types of question you should practice. All that we were discussing like as a strategy to get the best marks in digital electronics. And now in the today's class, we are first going to cover up the SR latch. Right, if you have a doubt in the mind ki what is a latch, what is a flip-flop, what is the fundamental difference between them, everything we are going to cover, need not worry. Yes, everything we are going to cover. So yeah, I see students joining slowly. Yes guys, so come on, let everybody join quickly. People are joining slowly. Yes, very good evening. Satya, Vishnu, Navneet, all very good evening. Okay, I think time to get started. Oh, okay, all cool. Good evening Jansi, good evening Shiva Kumar. Right, so guys, yeah, let's get started quickly then. Okay, so in case if somebody new to my session, this is a brief intro about me. This is your mentor and educator Rakesh, and I have secured all India rank 9th in the GATE examination, completed my masters from Indian Institute of Science, completed more than 11 years, having trained more than 50,000 students. My major area of expertise would include control system, digital electronics, signal and system, and electromagnetic theory in the technical domain, and I also deal with the mathematics and aptitude in the general domain. Right, good evening Kishan, Praveen, Jansi, very good evening all. Duration approximately 1 hour, you can say, Navneet. For the tech classes it will be approximately 1 hour, and we are going to come live daily at the same time, 8 p.m. So timing will be fixed, the duration will be approx 1 hour. Come live daily at 8 p.m. Okay guys, let's keep moving. And before we move, let me show you the Hall of Fame to give you a little bit motivation. Just let me keep you updated that the BYJU'S Exam Prep students outside in the GATE 22 examination, all India rank 1, 2, 3, multiple under 50, and many ranks under 100, all India rank 100. Yes guys, so now SR latch, the SR latch. First of all, why do we need the latch and flip-flop? Let me be very clear. If you don't know the difference between what is a latch and flip-flop, I am there to clear that also. But yeah, everything will happen in a sequence, right? First, why we need the latches and flip-flop, then why we first start with latch, why latches have little bit of disadvantage, why we go towards flip-flop, what is level triggering, what is edge triggering, what is a clock, why do we need clock devices, why do we need synchronization. Everything will happen in a sequence. All your concepts will get clear. You have to stay tuned throughout all the sessions. Acha, what are the different types of sessions? Right, what are the different types of session? Let me keep you updated. This is what is the sequence, and everything about latch and flip-flop right? The problems, the better thing, what is better, what is not better, everything is going to be covered in these sessions. That is from 26th April to 1st May. Today is SR Latch, then we go to JK Latch, D Latch, T Latch, race around condition, master slave flip-flop conversion, state transition diagrams, and the waveform based questions, right? So this is what we are going to cover up. Okay, now let's get moving ahead. Okay, so before we actually start up latches and flip-flops, let me present one simple idea. Okay, what actually the need arises, one simple example. Achha. Suppose that you have two 4-bit numbers. Okay, let us say you have two 4-bit numbers. Okay, how can digitally, okay, we add two 4-bit numbers? Say for example, I have two 4-bit numbers represented as A3, A2, A1, A0, right? B3, B2, B1, B0. How do you add these two numbers? Say for example, if you want to write down in binary as an example, right? I have suppose two numbers 0, 1, 1, 0, and suppose I have the number 1, 0, 0, 0. Let's say this is what is the number. Yeah, let me add up some carries and all those things also. Suppose I have the number 1001 and I have the number 0011, right? Now how you are going to add these 2-bit numbers, right? Jenna, the class will be 1 hour daily at 8 p.m. Approximately 1 hour daily at 8 p.m. Sometimes a little bit fluctuation can be there, plus minus 5-10 minutes. Right, sometimes it can be little more, sometimes it can be less also, right? Now when you add 1 plus 1 is 0 and carry 1, right? So whenever you add 2 bits, there will be a sum result and there will be a carry result. Okay, right? Similarly, when I add A0 and B0, there will be some sum S0 and there will be some carry generated, which I'm going to call it as C1, right? There is the initial carry C0, which is usually 0. In the beginning cycle, there is no carry, so we can call it as 0. Now 1 plus 1 plus 0 is again 0 and carry 1. So at every stage we can expect that there is a carry that is going, that may be propagated, right? So 1 plus 1 plus 0 is 0, carry 1, right? So similarly, when I add C1 plus A1 plus B1, so how many bits I may have to add at the same time? At the same time, I may have to add 3 bits, right? Now there comes a sum, again there comes a carry bit. Again there comes a carry bit, right? Now C2 plus A2 plus B2, like here 1 plus 0 is 1, there is no carry. There is no carry, right? Now finally 0 plus 1, that is again 1, right? You know the decimal conversion, this is 12, this was 3, this was 9, and the sum is absolutely correct. 3 plus 9 sums up to 12. We know that, right? You'll understand why I'm talking about addition here, right? Now, that means to add any particular stage, when I go to C2 plus A2 plus B2, there will be a sum S2, there will be some carry C3, which may be 0, which may be 1, depending on the combination of the numbers. C3 plus A3 plus B3, the sum is S3, and there may be a final carry, that is C4. So that means to complete the addition of any particular stage, I need to add 3 bits, right? 2 is the actual bits to be added and 1 is the carry. 1 is the carry that is coming from the previous stage, right? So for every stage I need 4 full adders. At every stage I need 4 full adders. If I directly use 4 full adders, that becomes a ripple adder, right? So we are not going into combinational circuits, but I'm just setting a platform ki what we actually need to do. So normally we can think that let us use 4 different flip-flops, each for one stage, right? That usually becomes a design of ripple carry adder, a parallel adder. But suppose I tell you, can I complete this design using 1 full adder? Can I complete this design using 1 full adder, right? That design will be known as a serial adder. That design will be known as a serial adder, right? Because if I have only 1 full adder, so what I will be doing? If I have, everybody, if I have the 1 full adder, I will do the 1 stage calculation, right? Using that full adder, then I will have to wait, and again using the same full adder, I will complete the next stage calculation and so on and so forth. So I can do the addition of 1 stage at a time, right? So serially I will have to go stage 1, stage 2, stage 3, stage 4, serially 1 by 1, but not in parallel. Achha. So the condition is, sir, I have only 1 full adder. That is what I am telling now. So suppose let us complete this design. Let us complete this design using the 1 full adder. No problem, sir. I can complete the design using 1 full adder. Okay. let me use a single full adder to complete this design. Just keep noticing with me, right? Now, what does a full adder have, right? What does a full adder have? So, in a full adder, you will have the 3 bits to be added, A, B, and carry in, right? And it will have 2 outputs, a sum output and a carry output. A sum output and a carry output. One by one, you have to feed the numbers here, right? So, how many numbers? I have 4-bit numbers. I have the 4-bit numbers coming up here, right? Which I store it in a 4-bit shift register. Now, don't worry what is a shift register if you don't know. Okay, that is not going to disturb our this class at least. Okay, सबसे पहले what I need to do, A0 and B0, and initially what was the carry? Initially there is no carry. Initially what is the carry? 0 carry. Okay, so the initial carry is 0. Now this full adder will first of all compute A0, B0 and plus 0. It will produce a sum and it will produce a carry. Now what to do with this carry? The carry that is presented, the carry that is generated by any particular stage, the carry that is generated by any particular stage is used in the next stage, na? The carry that is generated by any particular state is used in the next stage. So in the next stage, I need to incorporate this carry and then add with A1 and B1 and then add with A1 and B1. Where is my carry now? My carry is available here. Suppose this is what is C0, but I need to reuse C0. Right, I need to reuse C0, right, and reuse and apply where? I need to apply here. Now, one idea is directly connect, sir. One idea is directly connect through a wire. But if you just directly connect through a wire, and we know that wires will have negligible delay, what will happen? The carry that is generated, suppose a carry 1 is generated. Suppose a carry 1 is generated and that carry immediately comes and interferes with this stage calculation. What should be the carry right now? 0. But as soon as a carry is generated, it comes here and it also gets added. It will spoil our current calculation. It will spoil our current calculation. So what actually needs to be done? What actually should be done is that, yes, we need to send this carry here. We need to send this carry here, but actually, let us hold the carry for some time. Let us hold or let us store the carry for some time and reproduce it. Reproduce it at the appropriate time when it is required. So there should be a device which is going to store or hold this carry bit, right? Which is going to store or hold this carry bit. This device will usually operate with a clock. What is a clock? I will explain you why we need a clock. I'll explain you. But eventually we need a device which can store or which can hold this particular bit for a moment of time, and at the correct required time it will release the carry to be added to the... When it should release the carry? It should release the carry when the next bits are ready to be added. When the next bits are ready to be added. When the next bits are ready to be added, right? This is what is a rough design of a serial adder. I have not completed. There are some more modifications. Before we complete a serial adder design, we should know what is shift register, how does the shift register works. Forget everything, right? Just think about the idea that I'm telling, that using a single full adder, I need to complete 4-stage addition, and that is why the carry that is generated by every full adder needs to be stored for a particular time. We have to hold this carry for a particular time before it is coming and getting added to the next stage, right? Is this point clear to everyone? Right. I am just trying to say that in several circuits, there are several circumstances, then there are some bits to be stored. There are some bits to be holded for a particular point of time. And the device which is going to store 1 bit of information, let's start with 1 bit first of all, right? The device which is going to hold the 1 bit of information, is basically a latch or a flip-flop. What is the difference between them? We'll understand, right? Latch and flip-flop both can store 1 bit of information, right? Their working is different, their mode of operation is different, right? So what we understand is there are some circuits which will have some combinational part, along with that which will have some memory elements. Acha ji, right? Which will have some memory elements, right? The output of the circuit itself, This is the complete circuit including a memory device, and the output of this circuit itself becomes the input to the next stage. The output of the circuit itself becoming an input at the next stage addition, right? So this sum output, let us say this sum output depends on what? Everybody try to think. This sum output depends on what? It depends on A, B and C in. Where is the C in coming on? C is coming carry of the previous stage. That means the output of any stage, is dependent on the external input, as well as the previous output, as well as what is this? This is coming as a previous output. This is the output connected to the input and the next cycle. And that is what is one of the very fundamental definition of a sequential circuit. That is what is very fundamental definition of sequential circuit, right? Sequential circuits have combinational circuits plus memory elements, and the output of sequential circuit depends on, right? The output of any sequential circuit depends on, is a function of what? Function of external inputs, right? Whatever user applies, whatever the bits to be added, they are the external inputs, right? As well as the output also depends on one of the previous output, right? Like you are able to see, this is the general block diagram. One of the previous output, this is also one of the output bit that goes and is applied to one of the input pin, right? See, Satya, getting a job in software is relatively easy as compared to, performing well in GATE. You need to work out, right? You need to work out what went wrong for you, right? And then you need to improve your preparation accordingly, right? So now what went wrong for you, it's a detailed discussion. I cannot answer blindly, right? So yeah, what is not going right for you, try to focus on that, try to work on that. If required, message me personally on Telegram, right? But definitely GATE is a little difficult task as compared getting placed in a software company or software course, okay? Right. Yeah, to maintain that sequence only, to maintain that sequence only, we'll be using the shift register also. But what I'm telling right now, let's forget about shift register and everything. We don't know that much, right? First, we have to understand what is the requirement of a memory element. Okay, what was the intent of telling you this much of story is that there are certain point of time where there are some bits which we need to store, which we need to hold for a particular point of time, right? And the devices, the storage devices, which is responsible for storing one bit of information will be a latch and a flip-flop, right? First we'll start with latch, eventually we'll go to the flip-flop, right? Eventually we'll go to the flip-flop. If there is any confusion, keep on commenting me. This is a very basic definition of sequential circuits. Now sequential circuits are of two types, but I don't want to make it as a theoretical part, right? What are these two types? What is asynchronous circuit and what is a synchronous circuit? I will explain you today only, but with a little bit of example. Let's not only go over the definition, let's not make it theoretical, right? Let us first of all start the understanding of latches and flip-flops. And as I'm telling you, these are the memory cells which are used in sequential circuits capable of storing one bit of information. What I'm currently focusing, one bit of information. If you are able to store one bit of information, then we can go and think about storing 8 bit of information, 16 bit of information, everything will be possible. But let's take a 1 bit of information to be stored, right? In every latch or a flip-flop, there will be two outputs. Okay, one is for the normal output, which we usually call it as Q, and one will be for the complement output, which we'll call it as Q bar. The Q bar, right? Now, the designing and understanding of all the types of latches and flip-flop will actually depend, and actually rely on the design of SR latch. That is the most fundamental building block of the sequential circuit, a SR latch. Before we start a SR latch, let's have a quick review. Everybody knows it, but just a 1-minute review of a NOR gate. Let's have a quick 1-minute review of the NOR gate. Okay, ji. Let's have a very quick 1-minute review regarding to the NOR gate. Now, NOR gate, one of the universal gate. everybody knows we write down the NOR functionality as a plus b whole complement. And what is the truth table for this? What should be the truth table for this? Zero 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 one 1 0 1 1, right? Now it's just the reverse of OR, right? It's just the complement of OR. So 0 plus 0 is 0, but complement will be 1. 0 plus 1 is 1, complement is 0. 1 plus 0, 1, complement of 1 is 0. 1 plus 1 is again 1, but the complement will be 0, right? So just simply remember, whenever you are dealing with a NOR gate, if any of the input line is high, the output will be low. I repeat, if any of the input line is high, the output will be low. If both the inputs are low, then the output will be high, right? The basic review of the NOR gate. This is how the NOR gate functions. And now let's come to the design of SR latch or a NOR gate latch, right? Now, in the SR, guys, can you quickly comment in the SR, what does actually SNR stands for? Why do we call it as SR latch? Why not AB latch? Why not XY latch? Why not MN latch? There can be so many names, na? There can be so many names. There are two inputs, SNR, right? Why only S? Why only R? It can be AB latch, right? It can be XY latch. It can be PQ latch. It can be MN latch. Any two consecutive letters I can select, right? Why SR and what is the significance of the letters SR? That will all understand because that will depend on what is that input pin doing. What is the role of that input pin, we'll understand. Like why only SR is selected. So first, let's take it as any input. Right now, SNR is any input. You can name it as A, B, X, Y, anything. Okay? Point is understanding the functionality of this. And now to understand the functionality of this, let us start with a specific truth table. Writing down SR and both the outputs Q and Q bar. As I told you, every latch will have two outputs, a regular output, normal output and a complement output. Acha ji. Right. Now, let us start. Usually we start with 0, 0, but I start with 1, 0. The reasons also you will understand very quickly. Let us start with 1, 0. Then let us apply the combination 0, 0. Then let us apply the combination 0, 1. Then let us again apply the combination 0, 0. And then let us apply the combination of 1, 1. Then let us apply the combination of the 1, 1. 1, 1. Okay. Now, let's come to this picture. So, what is the combination I am applying? Let us remove this. Okay. So, what is the combination that I am applying currently? What is the combination? S1 and R0. That is the current combination that we need to apply here. Okay. Just a second. S1 and R0. Okay. That is the current combination we need to apply. Okay, now we know that, as I told you, if any of the input line is high, the output goes low for a NOR gate. So very quickly, input is high. Let's look at the second number NOR gate. Input is high, output should be 0. Now if the output is 0, the output comes to the input of the next NOR gate, that is the NOR gate number 1. 0 and 0. What is the NOR of 0, 0? When both the inputs are low, output is high. So what is the output state now? Q becomes 1, Q bar is 0. Q becomes 1, Q bar is 0. Let us fill the answer here. Q becomes 1, Q bar is 0. Right. Now I apply the input 0, 0. Now I apply 0, 0 at the input line SR. So R is already 0. Here let us apply the 0 now. Here let us apply the 0. Now everybody see, this is 0, but only a single 0 can't decide the output. So we need to see what is there on the other line. So what is there on the other line? The other line is connected to the Q output. So Q output, which is 1, comes here. What is the NOR of 1, 0? Any of the input line is high, output goes 0. Output goes 0, but sir, the output is already 0. Sir, the output is already 0. That means it doesn't change. So the 0 output runs and comes to the next line. R is anyway 0. 0 and 0. If both the input lines are low, output becomes high. It is already high. It is already high. What is, you changed the input, but what is the change in output you observe? Output remains to be same. Q is 1, Q bar is 0. Q is 1, Q bar is 0. So let us write down this here. Q is 1, Q bar is 0. Right. Q is the 1, Q bar is 0. Okay, everybody? Okay, all fantastic, good going, cool going. Q is 1, Q bar is 0. Now, SR01. Okay, SR01. Okay, so now I change the input combination S0, R1. Oh, where is that diagram? S0 and R is now going to be 1. So let us remove the current combination. Okay, let me redo it. Now S is 0 and R is 1. Right. Now, since the R is 1, let's look at the NOR gate number 1. Any of the input is high. If any of the input is high, output becomes 0. So this time the Q output becomes 0. Now, the 0 quickly runs through the wire and it appears here. What is the NOR of 0, 0? What is the NOR of 0, 0? 0 plus 0 is 0. Complement karke aayega 1. So, NOR output is 1. So, what do you see this time? The Q is 0 and Q bar is 1. The Q is 0 and the Q bar is 1. The Q is 0 and the Q bar is 1. That is what is the output now. Q 0, Q bar 1. Okay, everybody? The Q is 0 and the Q bar is 1. Now, once again I apply 0, 0. Why? Why? Kabir Mittal. No. Everything will come. Okay, right now I think Kabir Mittal, we have planned the sessions for mechanical and civil. Right. In general strategy videos we have prepared, Kabir, you can go through that. But yeah, very soon we'll bring up similar sessions for computer science and ECW also. How to score, the best marks like 75, 80 marks in that particular branch. Right. So don't worry, Kabir Mittal. Okay. Now 0, 0, S0, R0. Let us come here. Right. S0, R was 1, R ko bhi 0 kiya. Right. So now a single line 0 can't decide anything. So look at this, guys. Look at this. Q bar is 1. It runs through the wire and it comes here. It comes up here. NOR gate, any input high, the output goes 0. Sir, output is already 0. Output is already 0. Though this output 0 has again appeared here. What is the NOR of 0, 0? The NOR of 0, 0 is 1. So Q bar again remains to be 1. So that means again there is no change. Again there is no change. Q remains to be 0. Q bar remains to be 1. Q remains to be 0. Q bar remains to be 1. Right. Now there comes the last. When I try to apply SR both 1, 1. Okay. Yes, Aichara, it depends. If already one of the input line of the second NOR gate is high, the output will be 0. Right. Otherwise, if one of the input line is 0, so then it will wait for the second output. Sai Charan. Okay. Acha ji. Now both are 1, 1. Everybody, let us come here now. Both the inputs are applied as 1, 1. So now what happens? Okay, this is also 1. This is also 1. And we know that if any of the input of NOR gate is high, output becomes low. So this input is high for the first NOR gate, its output is 0. Even this input is high. For the second NOR gate, output becomes 0. Right. So clearly, this time both the outputs, which should be complement of each other, are 0, 0, are same. Right. Now, what is the quick remarks that we are able to make out from this truth table? If there is any doubt in this particular truth table, okay, please do comment here so that we can, make your doubts also clear. Now, what is the comment on this particular combination? Whenever you apply S0 and R0, you are actually maintaining the same state. 1 remains to be 1. Right. Here also you apply 0, 0. Here also you apply 0, 0. So you have the same output. If it was 0, it remains 0. If it was 1, it remains to be 1. Right. So we call it as the same state. So whenever you apply both the input 0, 0, the device remains to be in same state. It does not change the state. Okay. I can't say that the output is 1 or output is 0. Actually, output is same as its previous state. If it was 1, remains to be 1. If it was 0, remains to be 0. Right. But if S is 1, R is 0, then it was a clear indication that Q is 1, right? This Q is 1. The output, the normal output, right? The normal output. Yeah, I'll tell you that, Anil Kumar. The normal output becomes high. The normal output becomes set. And we say that my latch is now set. So my device goes into a set state. Set means, what do you mean by set? The output becomes high. The output is set now, right? When I apply S0 and R1, when I apply S0 and R1, what happens to the output Q of the device? What happens to the output Q of the device? The output is reset. The output is what? The output is reset. When I apply S0 and R1, the output is, the latch is reset. The output becomes 0. That means, just wait for the last state. Isko chhodte hain abhi. That simply means that if you need to set the device, if you want to make the output as 1, if you want to set the device, what is the input combination you should apply? What input is responsible for making Q equal to 1? The S input. When you apply the S input 1, you get the Q output 1, and hence we call it as the set input. We call it as the set input. If you want to reset the device, if you want to bring the latch into the 0 state, into the reset state, what is the input combination you should apply? S0, R1. So which input is high now? Which input is high now? R input is high, right? So this particular input is responsible for making the device reset. Device go into reset, and hence we call this as reset input. That is why the name is S and R. I told you, otherwise name can be anything, A, B, C, D, E, F, X, Y, anything you can name. But we name it as S and R because one of the input is responsible for setting the device, S. One of the input is responsible for resetting the device, that input is R. So according to set and reset, we have using the abbreviation as SR latch. Okay, if both the inputs are 0, 0, so that device doesn't change. So if you have to set, make the S equal to 1. If you have to reset the device, make the R equal to 1. If you don't want to do anything, if you want to maintain the previous state, same state, don't apply any input. S0, R0. Now, one is for setting the device, one is for resetting the device. If you don't apply any of them, then the device is in the same state, nothing happens. But if you apply both of them, what happens? If you apply both of them, what happens? So when you apply both of them, what actually happens that Q and Q bar, which are supposed to be complement of each other, are both looking to be 0, and we call it as invalid state. Right? Why we call it as invalid state? Is this the only reason that Q and Q bar are same? No, that's not the actual practical reason. Why we call it as invalid state? I will explain you its reason little later, right? I'll explain you its reason why there is a big problem. There is a big problem when you apply S and R both equal to the 1. It's just not ki Q and Q bar same. Itni si baat nahi hai, but there is a big problem, big disaster that can happen with the device. But to understand that problem, we need to learn little bit of the more basics. But I'll explain you this probably at the beginning of the next class. Okay. Probably at the beginning of the next class, I'll explain you this problem, and then only we move towards, actually, okay, D latch pe to jayenge, so actually JK latch, okay, is a modification in the SR latch to overcome this invalid state problem. So I will explain you the detailed reason behind the invalid state, and then we go towards the JK latch also. Okay, don't worry. Right, so I'll explain you probably in the beginning of the next class. Okay. So this is what is the truth table. Now let me see. Anil Kumar says why you don't take the previous outputs for some cases. Okay, Anil Kumar, for what cases I have not taken? If you go and see now. See, if any of the input line, R is what? R is an external input. Okay, isko bhul jate hain abhi. Suppose R is an external input and you apply R equal to 1, right? So, right, R is already 1. Whether there is 0 here or whether there is 1 here, is it going to affect the output? Because we know that in NOR gate, if any of the input is high, output becomes low. If any of the input is high, output becomes 0. That is what we know in the NOR gate, na? Right? So whether this output, the previous output, Q bar, whether it is 0 or 1, it doesn't matter. So only in that cases I haven't considered, right? But if this was 0, then I can't decide what is the output, Anil. So if this was 0, then definitely I will check what is there on the other line, right? Accordingly, I have chosen, right? Right. Saichana, that's what I told. Both outputs complement is not a very practical necessary condition. Yes, they should be complement, but what is the actual reason why we call it as the invalid state? The reason I'll discuss in the beginning of the next class. The actual reason, right? So I hope this truth table, this functionality is clear to all, so that we can go further. Now, this is what is the basic functionality of a SR latch. Basic functionality of a SR latch. This particular SR latch, let me mention what we are studying right now. This particular SR latch is an unclogged SR latch. This basically SR latch is an unclogged SR latch. Unclogged SR latch. Asynchronous. Asynchronous SR latch. Now, what do you mean by asynchronous and what is the problem? Now, let us understand the problem here. I told you, there are some definitions I will explain with example rather than going theory. So, if I go back to the previous slide, what is the meaning of asynchronous sequential circuit? Asynchronous circuit, which can be affected at any instant of time depending on the changes and input signal. That means inputs can affect the system at any point of time. Inputs can affect the system at any point of time. Right, that is a NAND gate. That is the NAND gate design. I am taking the NOR gate design. Both are different. You can go with any one, Navneet, actually. Okay, the S bar R bar comes in the NAND gate design. Okay, NAND latch. We are talking about NOR latch. You can go with any one of the design that is easy and comfortable to understand rather than going to both. Okay, so asynchronous circuit means, okay, the inputs can affect the system at any particular point of time. Now, the inputs can affect the system at any particular point of time. Now, let us once again, this is the conclusion already I have explained you. You can just go through this. Okay, everything will be available in the PDF. I will share you the PDF in the Telegram. Don't worry. Right, so this is what is the conclusion already explained to you. If S equal to 1, the device is set. If R equal to 1, the device is reset. If both are 0, then the device remains in the previous state, same state. Right, if both are 1, then this is an invalid state. The reason of invalid state, as I told you, I'll explain you in the beginning of next class. So this is already concluded, but now let's come to a larger picture. Okay, as I'm telling you, this is unclogged latch. So what will happen? Just try to now understand. Just try to now understand, right? Everybody. Okay, now suppose the device is initially reset. Suppose the device is initially reset. Try to understand the whole picture here. Let me write down in the form of a story. Suppose that initially Q equal to 0. Q equal to 0 means reset. Suppose that initially the device is reset, right? Your objective is to set the device. You need to set the latch. So what do you apply? Okay, what is the correct input combination you will apply? To set the latch, you will apply the input combination S equal to 1 and R equal to 0. You will apply S equal to 1, R equal to 0. Okay, let us say you apply S equal to 1 and R equal to 0. Okay, okay, sir. So initially it is reset. So now I apply S is equal to 1 and R equal to 0, right? I apply S equal to 1, R equal to 0 at initial time. Initial time we commonly take it as reference time 0, T equal to 0. I apply S equal to 1, R equal to 0, right? Now we know that practically every circuit or every logic gate will have some delay. It can be a smaller delay, but yes, there will be some delay. So now let's assume, let's simply assume that each NOR gate has a propagation delay of 10 nanoseconds. Each NOR gate has a propagation delay, TPD, right, of 10 nanoseconds, propagation delay. That means the time from the application of input till the production of the output, right? So I call this is having the propagation delay of 10 nanosecond. Both are identical and both the NAND gates are having the delay of 10 nanoseconds. Now try to understand the entire process. I apply S equal to 1 at T equal to 0. Dhyan dena. I apply the S equal to 1 at the initial time t equal to 0 and r equal to 0. This is what I apply at the initial time. Now look at the second NOR gate. If any of the input line is high, the output should become 0. The output should become 0. But after how much time will the output become 0? After how much time will you see this output? You are going to see this output after 10 nanoseconds. You are going to see this output after 10 nanoseconds, right? So this will appear at t equal to 10 nanoseconds. Not immediately. Nothing will happen like a magic. Nothing, in the world can have zero delay, right? So, maybe it can be fast like this, but it will have some delay, maybe microseconds, nanoseconds, but it will have some delay. So this output becomes 0 at 10 nanoseconds. So this comes here now. This comes 0 and the time is 10 nanoseconds. Now, both the inputs of the NOR gate number 1 are ready. Both the inputs of the NOR gate number 1 are ready. So now NOR gate number 1 is ready to produce its output. What is the NOR of 0, 0? NOR of 0, 0 is known as 1. When both the inputs are 0, the output becomes 1. So this output is 1. But after how much time? So this NOR gate will also take 10 nanoseconds, na? This also will take 10 nanoseconds. So already the time completed was 10. So here now the total time is 10 plus 10, that is 20 nanoseconds. Here what is the time? 10 plus 10, that is known as the 20 nanoseconds. That is known as the 20 nanoseconds. Are you getting it? So what is the final time required to set the device? Q becomes 1 after total 20 nanoseconds. Q becomes 1 after total of 20 nanoseconds. The Q becomes equal to the 1 after a total of 20 nanoseconds. So just see this particular table once again with me. Right. Now, I apply the S equal to 1, R equal to 0 at T equal to 0 and the Q becomes 1, Q bar becomes 0 at 20 nanoseconds. This happens, this is expected, this is what is the expected result. This is what is the expected result after 20 nanoseconds. This is what we expect after 20 nanoseconds. But now suppose that only at t equal to 8 nanoseconds. Suppose that only at t equal to 8 nanoseconds, there comes a glitch, there comes a noise, there comes a disturbance, and we all know that noise is a random activity. We never know when the noise is going to come, but suppose suddenly there is a noise, right, at t equal to 8 nanosecond, right, which changes the S input. There is an unwanted activity, there is a glitch due to which the S input becomes 0 at 8 nanoseconds. And let me call that as a noise, a disturbance which disturbs the S input, right, at 8 nanoseconds, because that is what I mean by an unclogged latch. What I told you, what we are studying right now, what we are dealing with right now, we are dealing with unclogged latch. Unclogged latch where input, even noise or any input can affect the system at any point of time. Yeah, forget noise. Let me make it even more simple. Noise, we don't know when the noise is going to come. Let me make it even more simple. Suppose I know little bit basics about the SR latch, but I don't know exactly what is the delay of the NOR gates. I just know the ideal functionality, right? I just know ideally how does this device work, but I internally don't know what is the timing required by the circuit, what is the propagation delay, I don't know anything, right? So what I will assume is I apply S1 and R0, the device will be set. I expect that immediately, and that is why I make the S equal to 0. Immediately after some time, suppose 7-8 nanoseconds ke baad, I make the S equal to 0, right? Because I don't know that there is total 20 nanoseconds of cycle required. So I make the input 0 at 8 nanoseconds. So you can assume either ways. Either I intentionally make it at 0 because of lack of knowledge, or a noise comes and disturbs the input at suppose 8 nanoseconds. Either of this happens. What is the end result? So at 8 nanoseconds, even this NOR gate has not produced the output. What is the time required by this NOR gate? 10 nanoseconds to change the state, and you are already pulling back the input at 8 nanoseconds. So will this make the complete transition? Maybe not. What do you expect? Unexpected results, right? This, you are not giving the circuit the required time, you are not giving the circuit the required time, and immediately what you have done is, at 8 nanoseconds, S becomes 0, R becomes 0, due to some noise or due to some lack of awareness of the user, you make it as 0, 0, and then you expect the output to be 1, 0. आप तो यही सोचोगे ना कि I made the input as 1, 0, you don't know noise has come. You will only say that I made the input S equal to 1, R equal to 0, but the device is not set. This is what actually it comes. This is what actually is come. So your intention of setting the device fails. You wanted to set the device, it is still reset. It was initially also reset. It was initially reset, it is still reset. Does it mean that there is something wrong with the circuit? Does it mean that there is something wrong with the circuit? No, there is nothing wrong with the circuit. What is wrong here? Your understanding of timing is wrong, right? You apply S equal to 0 only after 8 nanosecond. Yeah, maybe a noise disturbs the circuit and the circuit is not able to perform because of the noise. The circuit, the hardware is totally correct. This is what happens in asynchronous design. This is what happens in unclogged latches, where the inputs can affect. You are free to apply the inputs to the circuit at any point of time. At any point of time. Suppose I'm taking a class, and imagine that it's an offline class, hundreds of students are sitting in front of me, right? Suddenly two or three students, they were late and they come suddenly. The class has started, I am teaching, students are trying to understand, and there is a set of 2-3 students who enter my class randomly. They are allowed to enter at any point of time. What will happen? I am teaching, hundreds of students are trying to concentrate and solve some question or understand a concept, and suddenly 2-3 students enters, they will open the door, they will adjust the benches, they will try to sit, accommodate. That will create some noise. And that noise will disturb the whole system. It will disturb the students which are studying. It can even disturb my concentration. I am trying to explain something important. My brain gets disturbed. My concentration gets disturbed. That is what is asynchronous design, where inputs like students can affect the system, the class at any point of time. So what I did is, after taking several classes, let's take the class example. After taking several classes, I thought that there are many students which are, I regularly keep disturbed. This noise problem is becoming very common for me. So I thought to change the rule. I thought, let me not allow the students every time. Right. So what I thought is कि once I start teaching, देखो, just focus here. The door was open initially, okay, but the door will now close. And once I start teaching, I will keep the door closed. For a certain point of time, for a certain period of time. I will not make it permanently closed, because if somebody is late and if he missed the complete class, that is little injustice. Okay, so if somebody is late, I will allow that student, I will allow that input, but only after certain time, right? Till I teach a concept. Suppose I say 20 minutes I need to teach a concept non-stop. Suppose 20 minutes I want to teach a concept non-stop. I don't want any noise, I don't want any disturbance. So what I will do? I will close the door for 20 minutes. I will make a guard sit at the door. The guard will have what? The guard will have a key. A key to the door. And what is the role of the key? To open the door, to close the door as per my requirement. To open the door, to close the door as per my requirement. So suppose 20 minutes I want to teach non-stop, I will keep the closed door. And I will remain the door, I will keep the door to be closed, and then after that, okay, maybe, okay, I have taught some concept, I need little bit water, tea, something, I need a little bit break, okay, yeah, I need a pause. During that time, it may be small, it may be large, it may be small, that depends on teacher to teacher, that depends on circuit to circuit, right? But after a certain point of time, I can keep the door open for some time. And again make it close. This key operation, this door operation that you're looking here is fundamentally what we call it as a clock to the sequential circuit. A clock to the sequential circuit. We need to clock our sequential circuit in such a way that when clock is 1, like open means 1, close means 0. Let's relate it to binary now. So when the clock is open, when the clock is 1, then only the inputs can affect the system. And once I make the clock 0, once the door is closed, the inputs, the students cannot enter my system and they cannot create any noise. They cannot create any disturbance like this, right? So what is the first solution to this problem is to convert the unclogged latch, into a clogged latch, Now this is the same diagram. I have to convert it to a clogged latch. This is same unclogged latch. I need to convert it into a clogged latch. Clogged latch में convert करने के लिए I need to create a door and there has to be a key to the door. Like there is a door to classroom and there will be a key to it. When to open, when to close. So first let us create the door. Here is my door coming up. Try to see. Try to understand. Here there is the door coming up, right? Now, this is what will be my actual input S. This is what will be my actual input R. Right? Outside the door, I have the inputs, I have the students ready, but the door should have a key. The door should have a key. And here I apply the key, which is the clock pulse. In short, we call it as CP, which will be a periodic square waveform. That's it. Which will be a periodic square waveform, which is just going to be a periodic square waveform. So what I'm trying to do, it is the same SR latch, but a door has been created, right? A door has been created. There is a door, right? And the door has a key. Every door has a key. The key basically is technically known as a clock, right? And the door is built using two simple AND gates. The door is built using two simple AND gates. Sir, how the door works? Sir, how the door works, I will explain you, right? So this is what is the same SR latch. This is the actual input S and R. Let us call this input as suppose S1 and this input as R1, right? So what happens, it's a clear understanding ki if the clock pulse is 0, we all know the functionality of AND gate. We all know the functionality of AND gate ki if any of the AND gate input is 0, the output is 0. If any of the AND gate input is 0, the output is 0. If any of the AND gate input is 0, the output is 0. Correct? So, if the clock pulse is 0, that simply means the S1 will be equal to 0, the R1 will be equal to 0. The output of both the AND gates is 0. The S1 is also 0, the R1 is also 0. And if S1 and R1 both are equal to 0, sir, if S1 and R1 both are equal to 0, then what, guys? If S1 and R1 both are equal to 0, then what will happen? We know that SR 0, the device will not change the state. Okay. The device, the latch, does not change the state. Does not change the state even if you change external inputs. What are the external inputs? SR. So even if you change the external inputs, they are blocked. The door is closed, na? Right? The door is closed. Whatever may be the value of R multiplied by 0. यहाँ पे क्या feed किया? 0. R multiplied by 0 is 0. Nothing can reach here. Whatever may be the value of S multiplied by 0 is 0. So S and R cannot enter the system because the door is closed. Okay, the door is closed by a key. What is the key? It is simply a clock. What is the door? It is built using two different AND gates. That is, इतना ही so simple है ये. इतना ही simple है. Okay. So if clock pulse is 0, I can simply say that my door is closed. My door is closed, and that is why the inputs cannot enter the system, and if they cannot enter, they cannot affect the system, and that is why the system remains to be in the same state. The system remains to be in the same state, right? But if the clock pulse is equal to 1, that means the door is now open, and if the clock pulse is equal to 1, now see the output. Guys, clock pulse is 1, so what is R into 1? This is R. What is R into 1? Is R. So that means whatever is the external input now comes inside the system. Because the door is open, a student can come inside my class. Same thing, the door of the sequential circuit is now open and the input R can enter the actual latch. This is the actual latch we studied in the beginning, right? Similarly, S is here, the clock pulse is 1, S into 1 is S, and that reaches inside the system. S into 1 is S, and that reaches inside the latch. So inputs can reach the latch when the door is open, and then only they can affect the output of the system, right? That is what let us mention here. So if clock pulse is 1, the door is open, and S1 becomes equal to S, R1 becomes equal to R, right? Or either I can say S1 is S into 1, which is S. This is R into 1, which is equal to R. So S1 and R1 is equal to SR. That means the external SR inputs, now reach inside the latch and affect the output. How do they affect the output? Depends on the value of SR. We know S equal to 1, device will be set. R equal to 1, device will be reset, right? Device will be reset. That is how we build what is known as a clogged SR latch. What is known as a clogged SR latch. Now a quick equation and transition table, final transition table of this SR latch. A final characteristic table. We also call this characteristic table as transition table, state transition table. Simply a transition table or state transition table. A state transition table. Now we know that Q is the output, and we call Q plus as the next output. So let me write down this. What is the meaning of Q here? Q means the current output, the current state of the latch. So Q plus means the next state of the latch. Now we have observed that, if you have followed the video from the beginning, we have observed that the next state of the latch sometimes depends on the previous state also, right? That is what we were looking and describing. So that is why the next state should depend on the previous state. That is why it is included in the truth table, and of course SR is included, that is the external input, right? Yes, to an extent, and that is why, Navneet, we are next going to go into edge-triggered devices. Let me mention here, right? I can say that, one more conclusion I will match. Okay, so I can say that latch is transparent if the clock pulse is equal to 1. Transparent means it is open to the input. The inputs can enter the system if the clock pulse is equal to 1. Otherwise they can't input. So the system responds. Okay. The latch responds to a level of the clock. What is that level? Level 1 we have chosen. Okay, we can also choose reverse. Here we have chosen level 1. Whenever the clock is at level 1, the latch will respond. Otherwise the latch will not respond. And such a device is known as level triggered latch. This is a level triggered device, right? So clocking is of two different kinds, my dear students. One is level triggered, one is edge triggered, right? So of course there will be some problem in the level triggered also. Finally we go to edge triggered, and there comes the flip-flop actually. There comes the flip-flop. Flip-flops are basically edge triggered devices, right? But let us first complete this fundamental, the level triggered devices. So we first started with a device which is unclogged latch. There is no clocking at all. We identified the problem there, and then we said that, okay, let us introduce the clock, let us introduce the door. Okay, what type of clocking we have done? Level triggered. There will be a problem that we will identify in the upcoming classes that is known as race around condition. And then we go towards edge triggered devices. They are flip-flops. Okay, so I told you in this entire 6-7 class, all your concepts of clock, latch, flip-flop, all variety of question, everything will cover. You have to stay tuned for the entire 6-7 classes live with me. Okay. Chalo, now let us fill this table. Everybody, let us fill this table. S and R are both 0. 0, 0 means same state. So same state means copy this. If the current state is 0, next will also be 0 because it has to remain in the same state. Acha. S0, R1. R1 means reset. R1 means reset. S1 and R0. So whenever S is 1, then we don't need to check the previous case. Whenever S is 1, confirm the device will be set. The device will be set. Okay. Now let's come to this. Abhi isko skip karenge. Again 0, 0. 0, 0 means the device remains in same state. Same state means if it is 1, it will remain to be 1. Okay. Now 0, 1. R equal to 1, so device will be reset. S1, R0. S equal to 1, so device will become set. S equal to 1 means device will become set. Right. Now, next is what? Next is, if S is equal to 1 and R equal to 1, if both the inputs are 1, what we call this as invalid state. And I once again repeat that, what is the actual reason behind calling this as invalid state, we will understand at the beginning of next class. At the beginning of next class. Right, we'll understand that at the beginning of next class. Okay, so if both the inputs are 1, 1, if both the inputs are 1, 1, right, okay, the device will go into invalid state, and that is why as a user we have to assure that we don't apply this particular input. We don't apply S and R both 1. We don't want the system to go into invalid state, so we should not apply the input. So as a user we have to guarantee that S and R, SR equal to 1 should not be applied, right? And if an input combination which is never applied to the system, what is the output due to that? If the input is not at all going to be applied, we don't care about the output. Na? You might have studied about don't care condition in the K maps. You might have studied about the don't care conditions in the K map. So if an input combination cannot be applied, don't worry about its output. Don't care about the output. Output may be 0 or 1. Don't care. Right? Don't care about the output. It may be 0. It may be 1. We call it as X. We call it as don't care X. Now, let us quickly fill this truth table into the K map and get the Q plus functionality. Right? Get the Q plus functionality. So, let us do it quickly. Let us get the state transition equation quickly, guys. Let us get the state transition equation. So we have the three inputs Q, S, R, right? We have the three inputs Q, S, R. Q may be 0, 1, SR may be 0, 0, 0, 1, 1, 1 and 1, 0, right? We all know that in K maps we follow the gray codes. In K maps we follow the gray codes, right? So now the output is high at 0, 1, 0. Okay. Let me fill the combination now, right? 0, 1, 0 output is high, and then the output is high at 1, 0, 0, 1, 1, 0. This is 1, 0, 0. This is 1, 1, 0. Right? 1, 1, 0. Acha. Then output is don't care at 0, 1, 1 and 1, 1. 0, 1, 1, or this don't care, sorry. This has to be don't care, and 1, 1, 1. This has to be don't care. This has to be a don't care. Okay, ji. Now this is the K map. This is the K map. Okay. No, Neelam, students are watching from quite some time. The noise was there. Can you please refresh it? Okay. Now, finally, let us pair this and get the answer. Right. This is a group of 4 actually, and here it will be paired up. Here it will be paired up. This group of 4. Okay. We know that this is Q. Q is high here. What is high here? Here we have S high, and here we have the R high, right? So this is known as S, and this belongs to outside R and inside Q. So R bar Q, right? I hope you just remember the problem, you remember solving K map. I'm not going into K map right now. There are different ways of dealing with K map. Whatever you feel best, go with it and solve this K map. So what is the next state equation coming up? it is coming up as S plus R bar Q. It is coming up as S plus R bar Q. We call it as like the state transition diagram, we call it as the state transition equation. We call it as the state transition equation, or we also call it as characteristic equation of the latch. We also call it as the characteristic equation, or we also call it as the next state equation. There are multiple names given to it. The next state equation, the transition equation, are also known as the characteristic equation, which is simply known as Q plus is equal to S plus R bar Q, right? But this has been derived considering don't care. Why don't care occurred? We have taken the don't care with the assurance that S and R both should not be equal to high at the same time. User should ensure that S and R are both not equal to high at the same time. Okay, that means S and R, the product of SR should be 0. The product of SR should be 0. That is one more condition to be added. Now, when the product is 0, it will be either 0-0 combination or 0-1 combination or 1-0 combination, but it cannot be the 1-1 combination. It cannot be the 1-1 combination. So, this is the complete and correct representation of the characteristic equation of SR latch. Characteristic equation of SR latch, right? Then we simply have, the graphic symbol of the SR latch. This is two inputs SR, there are two outputs Q and Q bar, and this is the clock pulse which we apply. As we know that we are talking about clock latch, so clock pulse is also one of the input. This is just a representation, a graphic symbol, nothing much. Now I give you an assignment, guys. Okay, now I give you an assignment. This assignment will help you in understanding. Okay, determine the correct sequence obtained at P and Q. Guys, just a second. Okay, just a second. Just a second. I want to change the names here, just a second. So normally it should be Q and Q bar, but we know in the invalid state both are becoming the same. That is why I want to change the names here. Okay, let this output suppose be P, let this output suppose be Q, right? We have the two inputs SR and we have the two outputs PQ. The following binary values were applied to the NOR gate latch as given below. S1 R0, right? S1 R1 and S0 R1. This is what was applied to the NOR gate latch, right? Determine the corresponding sequence obtained at P and Q. This is P and Q. This is an assignment. We'll discuss this tomorrow. And with this problem, you will understand the actual reason behind invalid state. Why invalid state is troublesome. Why invalid state? Because when you apply S1 and R1, you will get the invalid state, right? Once a system enters invalid state, what happens next? That is a big thing to understand. Okay, so we'll discuss this tomorrow, guys. We'll discuss it tomorrow, and then we also discuss the JK latch, D latch and the T latch coming up in the tomorrow's class. So this is an assignment. Please try to solve this assignment so that we can study the different latches tomorrow, right? And let me once again tell you that this is the Hall of Fame BYJU'S Exam Prep students outside in the GATE 22 exam with All India rank 1, 2, 3 and many students under All India rank 100. And this is what is the entire schedule of the class. You can follow this class. So tomorrow today we have discussed about the SR latch. Tomorrow we go to the D latch, JK latch, T latch, and then eventually, as I told you today, what we discussed, level triggered device. Okay, once we understand, okay, first we study JK and T latch, then we go towards race around condition that will highlight the problem with level triggered device. Then we go to edge triggered device, that is basically the flip-flops. So every possible sequence we are going to cover here. So that means tomorrow, okay, at 8 p.m. tomorrow at the same time, 8 p.m. we'll discuss the next D latch, JK latch and the T latch. Right, guys, so with this, me Rakesh Talreja will sign off for the class. right? Hope you are enjoying it, and if you are enjoying it, do not forget to like the session. And yes, if you want many more similar concept, and if you want that you don't miss these sessions, right, do not forget to subscribe the BYJU'S Exam Prep GATE, ESE and PSU's channel, right? We'll keep bringing such more content, right? Yes, if you have any further doubts, you can also write it in the comment box. If you feel the doubts later, yeah, somebody watching it recorded, you can, post your doubt in the comment box. Okay, I'll reply there, and please do try to complete the assignment, and let's discuss it tomorrow, and also go towards the D latch, JK latch and T latches, then flip-flop, then state transition diagram, converting one flip-flop to another, and etc, waveform, timing based question, everything we are going to cover. These 6-7 days, everything about latches and flip-flops will be covered, including all type of question. That is what my assurance is. I only need that you should be regular. Then only this series gives you benefit. If you attend one, miss second, then attend third, it will not give you benefit. So try to attend. It's a matter of 6-7 days. Try to attend daily. The timing is fixed, 8 p.m. Okay guys, so bye-bye. Thank you. Stay safe. Take care. Do not forget to subscribe the channel, and let's meet tomorrow at 8 p.m. once again with the same energy, same Josh.